Good afternoon, everyone. Welcome to Integrating Salesforce Data with Heroku Connect and Postgres. Before we get started in earnest, I wanted to tell you a little bit about myself. As you can see, my name is Rob Zaire. I work on the product team at Heroku, and I'm focused on our data services, in particular Heroku Connect and Postgres, which will be the focus of this talk. Now, I've been at Salesforce for about 2 years. The whole time I've been at Heroku working on data services. My background is with advanced analytics, BI, OLAP. So I worked at Oracle and Microsoft. I actually spent a very long stint at Microsoft working on the SQL Server BI platform there. So this is kind of my passion. One slide you've no doubt grown tired of seeing, but I'm obliged to basically mention one key point here, which is any current or future purchasing decisions should be based on generally available features. Everything I show you today will be generally available. There is one feature I may speak to that's currently in the last stages of a public beta, and I'll call that one out specifically so that you know. Okay, so the agenda for today is an overview of Heroku Connect. We're going to talk about how it's used, what its capabilities and benefits are. I'll show you a demo, and we'll leave time for questions. Sometimes I know there's more questions than we have time to take in the room, so I just want to let you know I'll go outside of the room whenever we get kicked out, and happy to take any additional questions then. As far as sort of who this talk is geared for, it helps if you have some familiarity of Heroku, just sort of a basic sense, essentially fully managed PaaS and what it's used for. Familiarity with Salesforce, I think, is a given, and everyone in this audience has that. You don't need to know anything about Heroku Connect. That's really the goal of this talk, is to communicate what it is and what the value of it is. Okay, so let's start by looking at the landscape of data services that we have within Heroku. We have 4 fully managed data services that are not only designed to work together, but they're designed to be really easy for developers to use in their applications. Okay, so we really focus on developer use cases, not to the extent of pure data use cases, though. So if you look at, for example, Connect, and your main goal is primarily around data integration, then it's certainly going to be suitable for that as well. So we have Postgres, which is an open source SQL compliant database. We manage about 1 million clusters of Postgres. So that's something that Heroku has been doing a long time. We don't just manage and operate Postgres, but we have several people on our team who are contributors to that code base. There's Connect, which we'll talk about at length today. There's Redis, which is a high-performance, in-memory key value store. So really useful for caching database information. Also fantastic if you have a notion of a secure session and you need to enforce that time to life. Those are common use cases for Redis. And lastly, there's Kafka. So I think in many organizations, there's the awareness, but the use cases are still emerging. High-performance, distributed message bus for PubSub. So we offer that in both a multi-tenant and dedicated setup. So let's talk about Heroku Connect. What is it? What does it do? Well, as you saw, there's a theme around fully managed, and Heroku Connect is fully managed data integration as a service. It's unique within Heroku, within the PaaS, in that this is a SaaS offering. There's no code. You couldn't write code for it if you wanted to. There's very little configuration. It takes minutes. Really what you tell us is, what's the data that you want to synchronize? And you'll see the other settings. I'll go over them, but that's about it. So it's really more like a PaaS. It supports 2 data integration patterns. Okay, the first pattern is replication, and what that means is taking data from Salesforce, the data that's of interest to you, and physically moving it over to Heroku Postgres, and then keeping it up to date. You can also do bidirectional sync, and in fact, we'll talk about some of the use cases, but many times there's a need to do that synchronization bidirectionally. The other pattern is what we call data virtualization, right? And so we achieve this by via OData, Open Data Protocol. We have a wrapper over the Heroku Postgres database, and this enables easy integration with Salesforce external objects through external data sources. So those are the two patterns that are supported. Common use cases. So really common use case goes under the heading of extending CRM. And what we mean by that is extending the reach of CRM, extending your investment that you've made in CRM. So that takes the shape of applications, web and mobile apps, customer-facing app, field service app. Last Dreamforce, I gave a presentation with PricewaterhouseCoopers. They actually, a lot of their employees are consultants. They're super competitive. They were transitioning to Salesforce, so what they did was they gamified Salesforce, and that's essentially, it was like getting their employees to use Salesforce. All that's built on Heroku. The benefit is you take the data from Salesforce, you bring it into an environment where you're going to realize developer agility, a lot of flexibility when it comes to languages, 8 languages, multiple frameworks, all kinds of add-on services, and the ability to seamlessly scale that. So another one of our customers is a power company in Europe. They have millions of customers, and so they have a customer-facing app. It wouldn't be feasible to have those, that application hitting Salesforce all the time, right? So the data goes to Heroku, it populates the mobile backend, and then when changes are made, so a customer changes their service plan, they change their contact info, behind the scenes, Connect will synchronize that data back to Salesforce. So you retain Salesforce as the source of truth, but you use that same data to power the application experience. Another similar use case is around offloading complex processing. So you can imagine any business process that can be arbitrarily complex in Salesforce, you may not want to have that logic in Salesforce. Why? Well, you may not have a developer that's really good at Apex. You may not want to build a monolithic sort of conglomeration of all of your logic. There is kind of diminishing returns there. The more complex your Salesforce logic gets, at some point it's hard to debug. You can run into performance issues, right? So think of an example if you're applying for a loan, right, and you've got the process modeled in Salesforce. At one point, there'll be sort of a check the credit, give me this person's rate step. That is a great thing, for example, to offload into Heroku, where you could have a number of microservices do all the heavy lifting there, and then write the response back, for example, as a platform event, right? So that's the complex processing use case. Multi-org, there's a number of scenarios here. You may be in a company that has multiple Salesforce orgs. That can be because of geographic distribution, acquisitions, the adoption pattern. It can also be out of choice, right? You may have a sales-focused org, a service-focused org. So at some point, there's typically a need to rationalize the data across n number of orgs, right? You may be doing it because you want to get a unified view of an account or a contact. You may be doing it because you want to consolidate into sort of a master org. So again, Connect can really help there because, again, it makes it really easy to bring the Salesforce data over, lands in a database, you can do your transformations as you need to, and then use Connect to write the data back. And then the last use case, I'll spend the least amount of time talking about, it's analytics and insight, right? So you get the data out of Salesforce, once it's in a relational database, super easy to query. Any BI tool will support, JDBC driver. Most developers and IT folks understand some amount of SQL, and again, you can easily integrate, use it as a staging area to integrate with the data warehouse. So let's talk a little bit about the first pattern. This is the replication via what we call Heroku Connect Sync. I mentioned it was bidirectional. One thing to note, and it comes up a lot, is how scalable is the service, right? Because oftentimes I think we get trained that things that are simple typically have inherent trade-offs, right? It could be flexibility, it could be scalability. There isn't a scalability trade-off. There is, I think you'll see, a bit of a flexibility trade-off because, again, you're not able to write code, right? We take care of the integration. But from a scalability standpoint, we operate in 6 global data centers. These are all the data centers that Heroku runs in. If you don't know, Heroku itself is built on AWS, so these are all AWS data centers. We have over 15,000 customer instances. We manage over 15 billion rows of customer data. Some of our largest customers are well north of 1 billion rows of management. So Connect is able to operate at scale. Another question I got, I was in the booth yesterday, they were asking about dynos. Do you have to buy dynos as a part of this service? The answer is no. This is one of those services, frankly, if I was on the team when we developed it, I wouldn't have developed it this way. You don't pay, there's no paying for performance. You just, every customer from the smallest to the largest is entitled to have this service work as fast as possible. We have all kinds of operational metrics and automated processes that essentially scale the service as needed. So we hit our SLAs. So you don't have to worry about dynos. It's just about how many rows you want to have synchronized. Again, performance is something we take care of. You're going to see here how easy it is to set it up. It's literally just point and click. There's nothing more to it. There aren't really many Connect-specific concepts. And then I think the power we talked about before, right? Once you have it in a relational database, there's a whole lot you can do with that data, including synchronizing it back to Salesforce. For the folks who are more curious or maybe more technically minded, I'll take a moment just to explain in brief how synchronization works with Connect, okay? Firstly, when it comes to how we determine changes, we do it by polling. So Connect has an engine in the background, and it's polling for changes. We look at the system mod stamp within Salesforce. By the way, that's an internal technique we don't recommend there's some pitfalls, so we don't recommend that for customers. And what happens is, there's a polling interval, as you'll see in the demo. That determines how often we go and check. But then we can also use the streaming API. That's an option you can select, which will basically have us get notified by Salesforce when the data changes, and that will trigger a poll, okay? So it's always polling. It's just whether it's a scheduled poll or an on-demand poll. And in fact, even when you're in the on-demand mode, we'll always check at the polling interval just to be safe. When it comes to reading data, so Connect will read data in parallel. It's highly parallelized. You can actually, it's a more advanced topic, but you can actually have multiple Connect instances work against a single Salesforce org. But that can actually be too much load on the org, because again, it's highly parallelized in how it reads. Reads and writes, in fact, happen in parallel. Writes happen in a serial fashion, very fast, but there's reasons for that have to do with data integrity and how we log the data. But what we do, if you're familiar with a write-ahead log in a database, essentially logging all the operations, we maintain a table where we log all the operations on objects that you've mapped. So the ones that you've told us you want to synchronize with Salesforce, we track those changes, then we essentially, it's like a queue, and when we work through that queue and flush it, and we can use multiple techniques to do that. Consistency is a topic that comes up. Will Connect always be in sync with the Salesforce org? And you may have inferred the answer by how I described how it works. The answer is no. It will eventually be consistent. But at any given moment in time, you've got multiple threads reading and writing data, right? So that's one thing to keep in mind. It typically isn't an issue. It's more of like if you do a spot check and you may see there's a little bit of a delay. And the last point is conflict resolution. So how do we, with all this activity happening in parallel, you've got a busy Salesforce org. How are conflicts handled? And it's really simple. When we're synchronizing data, Salesforce is the source of the truth, right? Salesforce is the source of the truth for customer data. We treat it that way, but we have a real simple model. It's last writer wins. And what we know in practice is we'll never be the last writer. Okay, your application may write a change and into Postgres, and we'll synchronize it, but obviously there'll be many other processes interacting with Salesforce. So that's why we say last writer to Salesforce wins. Okay, on to the second pattern before we move on to it, before I show you a demo. Heroku External Objects is our fancy branded name for, again, an open data protocol service, an OData wrapper around the data in Postgres, right? So this enables any OData-aware application. Obviously, it's part of Salesforce, so we thought a lot about Salesforce Connect. But any OData-aware client can interact with this because it's built to an open standard, okay? So one thing that may not be obvious is even though the data isn't physically moving, you can, via Salesforce, for example, write a change back to this virtual object and have that change propagate through the service back to the database. Okay, so it's bidirectional. There's a small caveat there that we support both physical tables and database views for reads, essentially, but when it comes to writes, we only support that for physical tables today. It's efficient, right? It can be the preferred way to go for a number of scenarios. Let me give you one. if you have data, that's summarized data, aggregated data in a data warehouse, and you want to surface this back through Salesforce, let's say for your sales team, in the context of an account, okay? So you want it to be contextually relevant. This is a great option, right? Because literally you'll get a very focused query that'll pull the aggregated metrics for that account on demand when the salesperson is actually looking at that data. In my opinion, a really suboptimal solution would be like, hey, let's take all the data from my data warehouse and push it into Salesforce, right? Bad idea. A low-level data use case can be, think of a Service Cloud case, where if you are, for example, you sell connected devices, say a refrigerator or a microwave stove, and those devices are continuously emitting events. They eventually get aggregated, end up in some system where you track those. The customer gets notified, hey, there's something wrong with your refrigerator. They call you, you log a case in Service Cloud. Within the context of that customer record, when you go look at the data, you see, hey, there's something wrong with the refrigerator, right? Like you have a view that'll say, errors over the last 24 hours, 7 days. Really useful to see that in context. Really bad idea to move that type of data into a CRM, right? It just doesn't belong. So that's where the efficiency comes in. Again, you'll see how easy it is in the demo to set it up, and the power here comes from, rather than being a database, which is really well understood, the power here comes from being able to take data from an external data source that's kept in a logical external data table, surface it as a Salesforce external object that you can then incorporate into business processes, and more or less, there's some limitations, query as a native Salesforce object, or I should say work with. So with that, I'm going to pop out and show you guys a demo of Heroku Connect. Should I make this a little bit bigger, visibility-wise? Is that good? Okay. So what we're looking at here is actually the Heroku dashboard, right? And I've got a really simple application, and I just wanted to show you here that I've added Postgres and Connect. These are add-ons that have been added, right? And I've got multiple add-ons. Excuse me, it looks like I had to re-authenticate. So as far as beginning the workflow, it's really easy. It's just, you say, look, I just want to add an instance of Heroku Postgres. What level of plan do I want to add? One thing I'll note for you is everything I'll show you today, and in fact, just about everything in Heroku has a free tier. So there's really very little barrier. If you just want to get started and play with it, we have a free instance of a plan for Connect, hobby plan for Postgres, which is free, and you can connect that to, for example, a Salesforce sandbox and test it out yourself really easily. So it's as simple as, provisioning there's really nothing more to it than that. Connect is very much the same. I'm internal, so I see this QA plan. Again, provision that. It's ready to go. I'll just click on Connect, and that'll walk me through a really simple provisioning workflow. And all that is essentially associates your instance of Connect with an instance of Postgres and an instance of Salesforce. So Connect is always a part of a triad with Postgres, Salesforce. Okay, let's actually go in here, and I'm going to go into this empty dashboard, right? You can see here, excuse me, that I haven't mapped anything yet. And the way that Connect works is you have to specify mappings. That's essentially the instruction around synchronization. So the first thing we'll do, and I'm just going to create one mapping here for you, is just click on this Create Mapping button. This is going to query Salesforce and bring back all the objects that exist in my org. So we'll just grab accounts. Right. So now I've said, okay, I want to map the account object, and now we're going to bring back all the fields, and it'll expose some of the settings that also exist. So let's go through the settings, and let me tell you about how this works. The first thing is the polling frequency. You remember I said Connect was polling-based system. So you're able to set the polling frequency anywhere from 2 minutes to 60 minutes. Then you have this option to click Accelerate Polling. And this is the option for streaming. So what we'll do is we'll create a push topic on the Salesforce side. That'll give us a channel through which to get notified when data changes. So let's say we do 2 minutes. We're 30 seconds into that polling interval, and we get notified from Salesforce that the data changed. we'll then initiate a pull in response to that notification. So really simple. These two settings actually give you some interesting scenarios, right? Like if you have an object that is infrequently updated, yet you want to know as soon as it does get updated, you can set the polling interval to be longer, 15 minutes, 20 minutes, 60 minutes, but then enable accelerated polling. So you can play with those a little bit. This option here, write database updates to Salesforce, this is what makes it bidirectional, okay? And then lastly, you can see that there's a number of fields here. You can index these independently, or you can have Connect essentially create an index for you as well, right? So really simple. And that's essentially, see, all that exists. So I want to show you something that we've built into Connect. One of the things that we realized, this service has been GA for almost 4 years, is that even with a simple service, customers can get into trouble because some things aren't always self-explanatory. So we actually created a set of best practices. These are things that were actually recommended patterns or anti-patterns, right? And so we embedded those into the product, and what we do now is as you actually use it in real time, we'll validate whatever settings you've picked and then notify you if we feel like, well, if essentially it triggers a validation error. So that's what's happening here. What it's telling me here is that, look, I've got, you made the mapping read-write, you should have a unique identifier. And this is basically to prevent collisions, as before we get an SFID, when we read, the secondary identifier gives us a way to uniquely identify that role. So, and there's another issue here with the calculated column. So let's go ahead, and so you can see here, it's really fast because it's a small amount of data. And so that mapping is done. And this literally all there is to doing the synchronization. If I want to set up external objects, again, super easy. I'm creating this OData service for the data in my Postgres database. So that's as easy as hitting create the credentials. It's going to generate a URL. You can see this is an OData 4.0 URL. And what I would see in this list is all the objects that I've mapped from Salesforce are now available in addition to any other objects that are in the database, right? So it's, again, it wouldn't be limited to what came from Salesforce. In fact, again, typically you might create a view to aggregate some data, to join data from different tables, and then surface that back. Okay, so we've done that. Let me move over to another instance of Connect that has a lot of extra data. In fact, it has so much data because we have a little process that runs in the background that we call a hamster. And you can think of the hamster on the spinning wheel, and it's just shoving data in. It's putting so much data in that we've actually exceeded the limits for the streaming API. And this is another example of how we will tell you in the user interface, here's the problem. Here's when it happened. Here's a link to learn more about the error. So again, we try to make this service really easy. We realize it's not someplace you're going to spend all of your time in. So when you do come in, we try to make it easy. A couple of things to point out. If I go, as this is loading, it's going to take a little bit of time to bring the data. Everything gets logged in Connect, right? So there's detailed logging that happens. You can use this interface to filter the logs. You can also set up what's called a log drain. The log drain is just going to use the logging provider of your choice that you specify, and all the Connect data will get logged there as well. So you've got flexibility. We maintain a certain amount, I think it's 24 hours of log data ourselves. If you put it in your own logging environment, then you'll have a little bit more flexibility. So I thought I pressed the correct one, so we'll see if this comes back. It's quite big. So here's a view where you can actually see detailed data for all the records that have synchronized. So this is the SFID. I'm going to go pick one. There's no timeline here. Let's see if we can find one that actually has a little bit of a timeline, if I can find. There we go. So you get this very visual display, and if there's multiple change events over time, we'll keep those, and so we'll allow you to see, hey, here's the last value that was updated. These are the fields that were mapped, in this case, for the contact object, and then the actual data will show you the current data in Salesforce and the current data in Postgres, and you can compare the two really easily, okay? So that's it from the demo front. Let's go ahead and get back for the remaining slides, and we'll talk through those. So you may have, at this point, asked yourself, we get asked this quite often, why would I use this service and not just code it myself, right? Or I'm sure that every single person in this room is in an organization that has at least one ETL tool. It's really common, right? And the fact is, you can do it yourself. You can write the code. We don't use private interfaces. We use publicly documented bulk SOAP interfaces. There's no magic there. What we do offer, though, is all the API calls made by Connect are free. So when you do an integration at scale, those calls add up. So every API call, irrespective of the API we use, is free. We understand the Salesforce data model in depth. There's a team of multiple senior engineers that do nothing, and they've done nothing for the last 4 years, and they just focus on trying to get this problem right. And we are in Salesforce, we're part of the platform, so there's a lot of care and thought that goes into making sure we understand not only the data model, the API changes that happen with every release. We do things like handle maintenance windows automatically. So when there's a Salesforce maintenance window, or for any other reason, if there's a lack of connectivity to Salesforce. Now imagine you're that European power company, millions of customers, right? It can be hundreds of thousands of changes that are continually coming in. What happens? So what Connect will do is it'll just queue up all the changes and wait and keep checking. And as soon as Salesforce is back, the maintenance window is finished, for example, it'll flush the queue, okay? Is that something you could do on your own? Certainly is. It's just extra work and code and testing. So it's something we do automatically. We automatically use the best API for the situation. So if it's an initial load, we'll use the bulk API. We take advantage of Salesforce's native PK chunking, which if you're not familiar with that, it's just the way to take a really big job and split it up into bite-sized jobs, and so you get a stream of changes in effect. We also do the same thing when you're writing data from Postgres to Salesforce. This is the one feature I mentioned. It's not yet GA. It's public beta. It's going to GA in the next couple months approximately. But it's bulk writes from Postgres to Salesforce. It makes a huge difference in the performance and the throughput of those writes. Error handling and recovery, you saw how we log things. We have, there's detailed logging that happens around everything that Connect has done. Again, that's something you'd otherwise have to go take care of yourself. This really helps when there's an issue. And so we have 24/7 developer support. You have fairly easy access if and when you need it to the engineering team, which I think is kind of rare. And every Connect customer gets this 24/7 support, right? So if you have a production issue, there's a really short SLA. I think it's 30 minutes before your first contact. Might be even less. And you've got a team of folks that'll support you with any issues you're running into. How does that happen? Yeah, so great question. So the question is about relationship intelligence, and if you've got a master detail or parent-child type of relationship, how do we maintain relational integrity? In order for Connect to work in the parallelized fashion it does and to handle those scenarios, we don't actually model, right, the RI restraints. We'll bring over the data for the keys, but we don't actually define any of those constraints, and that basically allows it to work. Yeah. So I will spend just a little bit of time. We talked about sync and we talked about external objects. I just want to leave you with a little framework in terms of when you think about which to use and why. So when it comes to sync, obviously we talked about it. This is physical data movement. It's replication. Latency, in practice, another common question, seconds to minutes, right? Why do I say seconds to minutes? Because of the physics that's involved, right? So as the data volumes go up, the number of mappings, the number of fields that are mapped, the size of the records if you're mapping multiple large text fields, for example. All these contribute to latency, but in practice, seconds to minutes. It's asynchronous, as we talked about. A lot of stuff is happening in parallel. It's eventually consistent. And it can work in either a unidirectional or bidirectional fashion. Okay? External objects, again, it's no data copy. It's all virtualized. It's real time, all right? So the latency is really limited to how long it takes to call out to the web service, issue the query, get a response for the query, format the results, etc. So, but that's the main thing, is query execution time. It's a synchronous operation, right? You're issuing a request, you get a response, and it can also be bidirectional, as we talked about with a caveat around views. Now, when you choose between these two, and you're thinking of which do I use, it's actually, in many cases, again, they're very complementary. So you may find yourself wanting to use both techniques, okay? Synchronization, the data that you sync, it should be when Salesforce is the source of truth, okay? It's inherently Salesforce data. You want to get it out to do something that solves a business problem. You've got to be okay with a little bit of latency. It's not real time. If you need to, for example, issue complex, broadly scoped queries, so think of analytical queries where you're specifying, inline aggregations and effectively doing large table scans, it's great. You put it in the database. You have a number of techniques and performance optimizations available to you, and so you're fine. External objects is different. It's fundamentally, the data, it does not belong in Salesforce, but it has contextual relevance, okay? And if the real-time view is important to you, that's going to be a bonus as well. The queries, they don't necessarily have to be super simple, right? But it's not going to be a good user experience if they're very complex queries and the user is just sitting there waiting for the UI to populate the data. So typically, you don't want these to be super complicated queries. Now, you can have a fairly complex, let's say a materialized view on the back end, right, that's doing something complex, and that's a way around that issue. So I'm just going to close by recapping some of the benefits of Connect, and then we're going to have, looks like, at least 5 minutes for questions plus whatever extra time we have, okay? So we talked about Connect is highly scalable, right? Don't let the ease of use fool you. We operate in the, again, 15 plus billion records under management. It's adaptive to how you use it, the amount of data changes that have to be populated. It makes these decisions for you, so you don't have to, okay? Highly parallelized, right, in the name of performance, and the experience is very much guided. So as you're using it, even as a first-time user, if there's a value you haven't specified, if you're doing something that we consider or we know from experience to be an anti-pattern and a problem certainly at high scale, we'll let you know at design time, effectively at day zero, right, rather than getting the bad news later. And again, allows you to focus on business value. So when you look at this versus, the work you have to do to actually do this in ETL, the way I think about it is it's probably one full-time engineer. And it's going to be someone who's reasonably senior if you want this thing to work and work right over time. So that's really the value. Don't think of Connect versus ETL. It's kind of like Connect versus one person, one sort of expensive, highly time-constrained user, right? So that's how I think about it. Again, it's fully managed, 24/7 support, and I would encourage you, if you have interest in the service, give it a whirl. We have a free tier for everything. It takes just minutes to set it up, and you can see how it works in practice. Okay, so with that, I want to thank you for your time, point you to some additional resources. These will be in the slide deck should you want to grab it later. There's multiple trailheads, and again, thanks for your time and attention today. I appreciate it. Okay, and I'll take questions now. Sure. Go ahead. Would you mind, we're recording this, so if you could ask the question, it'll help the...
Yeah, you mentioned ETL, so how does it compare to a service bus like MuleSoft or Boomi?
Yeah, good question. So how does it compare to a service bus? It's a different paradigm that we use, right? So this is actually, essentially this is replication, right? So it's a point-to-point, whereas one of the benefits of a service bus, and I think is a really compelling benefit of a service bus, is you get the one-to-many fan out, right? So you put it in one spot. You're loosely coupled to the downstream consumers, and you can have n number of consumers rather than having to maintain n squared integrations for all your sources. Now that's a pattern, by the way, that I think is certainly the future of integration. I also think there's an ease of use in what this does, and it's very narrowly focused, but it does it really well. So depending on your scenario, this can be a good approach, and in other scenarios, it might make more sense to use that bus model. Okay, let me go over there, yeah.
So the Postgres database where the data is being transferred or replicated, can we add additional, our own indexing or additional columns which are aggregating data and all that?
Absolutely, absolutely. You can add your own triggers, your own views, your own tables, right? There is the thing that we advise against is if the table is managed by Connect, that you don't want to. You can define indices on them, and we have documentation that advises you if you want to build triggers based on the data in those tables. But as far as extending that data model, you should do it outside of the object that's being synchronized.
Got it.
That's the only limitation.
Okay, and how does it affect the performance of writes to that database if I may go
Doing a bunch of
crazy
things?
with the indexing?
Good question. So every once in a while we get support tickets from people who have done a lot in terms of logic in the database. And so that is something to be aware of. And that's why we essentially wrote a guide to building triggers and against Connect tables to help you avoid that. But it can become a performance issue, absolutely. The same way it does in any other database. Yeah.
And then is my Salesforce object aware that it's there is a connect, so that when I'm adding or extending it, it warns me that there is a connect?
Yeah. So it's what you described as a sort of the bane of the integration, right? Developer, right? Because what happens is on day 0 you define an integration, and then the world changes. So how do you handle that, right? So Salesforce isn't aware. You'll have an integration user that you'll use for Connect, right? And so from an auditing standpoint, you can see exactly what's happening. Connect is aware, though. We implemented a feature this year we call schema change detection. So we run jobs behind the scenes, right? So we've got sort of put together a big data stack, and we're continually monitoring. We snapshot Salesforce, and we snapshot your mapping at the time that you define it. And when something changes, we'll then detect that and notify you.
Okay.
Not just that something changed, but exactly what changed and how. So was a data type changed? Was a data length changed? Was a column deleted? Was a column added? It's very specific. And so it's designed to make that easier. And so you'll get an email notification around that.
So data type changes are handled automatically, or do I have to do anything for that?
There's a couple of exceptions where it's safe to do, and we handle those automatically. But generally speaking, we want you to come and look at it.
Okay.
Yeah. Thanks. Thank you.
So you said you were keying off, at least on the Salesforce side, you're keying off the mod stamp time.
Yeah.
On that, right? Is it the same on the database? For
We use
database changes?
We use a PG notify, so internal mechanism to Postgres to be notified. Yeah.
Okay, so that's how you account for deletes?
Yep.
Okay, thank you.
Sure.
One of the things you showed us had an issue with the streaming API limits being hit, but I thought I heard somewhere else that this doesn't count against.
Yes. Man, you guys are asking the best questions. I mean that. Okay, so there's a nuanced thing around streaming API. There's two limits, type of sort of dimensions of limits. I think you already know this, but for other people I'll mention it. One is the number of events generated. The other is the number of topics. We are whitelisted for number of events, meaning those don't count against you. Number of topics is not. What's happening there, I think, is a topic issue. But we're also operating in a QA environment, so there's some other things that may be happening. But as of spring 2018, the whitelisting for streaming API kicked in. So that could be yet another issue if the org there isn't on the spring 18 release, which is why you saw it. But I've had to confirm specifically for a number of customers that this was working. So, yeah.
And one other question. mentioned the two-way sync. Is that per table or is that everything?
It's actually per table, so at the mapping level.
Okay.
Yeah.
Cool.
Thank you. Sure. I'm going to go over there.
A couple questions. So you mentioned a dedicated integration user. Is that a license that we have to pay for in addition, or is that something that comes with paying for the service?
You have to have, so your org, you have to be, your org basically has to have, allow API access.
Right.
So I'm assuming that's not an issue. The user is just a regular old user. You're not going to sort of, right? And that user, to have Connect work with optimal performance, you just want to make sure they have view all permissions to every mapped object. Not globally,
Right.
but just to every object you map, because otherwise every single row will get evaluated against the security.
Okay. But it is a license that I have to pay for, an additional seat that I have
It
to
is
pay
an
for.
additional seat. It
Okay.
is, yeah.
It doesn't come bundled with what we're paying
No,
for.
I never thought about that, but it probably should for the theme, but no, it doesn't today.
Okay.
Yeah.
Second question is with data virtualization, is the availability or the accessibility of that object to the point where I can have a third-party tool? So, for example, marketing, right? We could have insane amounts of data that we want to pull from. We don't want to store it in Salesforce because the data storage limits and all that sort of stuff. So we store it in Heroku. Can my marketing, like if I have Marketing Cloud or something like that, can it access that data?
Any first or third-party app can access that data.
Okay.
Yeah.
Thanks.
Sure. I'm going to just flip over here and continue the trend of flip-flopping. So, yeah.
Great presentation, by the way.
Thank you.
So, a really silly question. Heroku Connect and Salesforce being so tightly integrated, does Heroku Connect respect the ownership, sharing rules, field level restrictions when loading data into Salesforce?
No, it doesn't. I mean, basically, so the way that that's going to work is, and that's a longer topic around sharing, but essentially, if you map that data, then we are going to load it.
And then it could cause some inconsistency in Salesforce then?
Um,
Because the user might end up getting some data that he's not supposed to receive.
When you say not, so it's the integration user will have access. So we can only map what the integration user sees, and so we ask that the integration user have view all data permissions.
Okay.
At which point, you can then use Postgres credentials to secure that data. But what doesn't happen, I think maybe is the root of your question, is there an alignment between sort of the security model in Salesforce and Heroku? Do we try to replicate that? We don't. Yeah, it's just it's too complicated, too rich, and we feel like that we would spend years and there would always be edge cases. So what we just recommend is you have to secure it there as well.
Okay, one more quick question.
Sure.
How many levels of relationships does Heroku Connect understand?
Levels of relationships?
Like Tree API has a 5-level limit, right? So is there a limit on?
Not that I'm aware of.
Okay, cool.
Yeah,
Thanks.
thank you.
So when Heroku Connect writes back to Salesforce, does it lock that particular object
No.
in Salesforce? It
No,
doesn't.
doesn't lock.
So
What we
if-
do see is, so generally speaking, we don't lock in the database, and we're not going to lock in Salesforce. What can get you into trouble, which goes back to the question from earlier, is if you have a long-running query, let's say, in the database, that sometimes we see that our writes will get queued up behind those. So essentially, this transaction is running out of control, or a query is consuming all the resources. But we don't do locking.
So it will just queue up, right? After the process is finished in Salesforce, it will write it on top of that, right?
It will, unless we receive. So there's we will issue the write. If the write fails, which is different than when there's no connectivity, we queue. If we issue the write and we're notified of a failure, then we log those really clearly. And there's 2 write algorithms. I didn't talk about those, but if you want to leverage bulk writes, you want to use the ordered write algorithm. And what that does is it takes every record so every instruction, every change to the database, we treat as an atomic instruction, and we write that one by one. Okay? The issue there is if the first thing that fails is an insert, subsequent updates will fail. So you have to be careful there, but you get better performance because if there's enough continuous operations of the same type against the same object, it's 2,000 is the number, we'll go into bulk mode. The other algorithm, merge writes, has a healing function, which basically says if we see updates and we don't see the insert, then we merge them together, right, as an upsert. So.
Thank you. I have two
Sure.
questions.
Yeah.
Salesforce has a compliance aspect of it, security.
Yeah.
How does Heroku match up to like HIPAA compliance, all that stuff?
Great question. Yeah, so we GA'd HIPAA, Vic, keep me honest here, like about eight months ago-ish? Yeah, I think it was Dreamforce. So we announced general available HIPAA compliance. It's non-uniform across Heroku, right? So we
these
have
two components, like
okay, it's great. So Postgres is HIPAA compliant,
yes,
and we are disclaimer from that second slide or whatever it was, but we are in the last stages of certifying Connect for HIPAA compliance. We're very close. That will be a fairly big announcement. So if you look at either the engineering blog, certainly our little change log, and anything else that Vic runs our marketing team. So anything else he puts together, but we'll sort of announce that far and broad. But very close to having that.
cool. Second question, I come from an organization already on AWS. All our data is stored in, for example, RDS in a MySQL database. Does Heroku support, I would guess, peering between
you do.
Heroku and our organization in order to kind of have that next hop?
Yep, we do.
Is that what you recommend, or
I do recommend it. We have many customers that use what we call Heroku private spaces, which is basically your dedicated Heroku
VPC.
everything VP, but it's a VPC, and so you can peer to that. There's one, and so I'll share an implementation detail here to illustrate a limitation and how we're going to resolve it. In private spaces, there's two underlying VPCs, one for runtime, one for data. You can peer to the runtime one. The data one today relies on IP whitelisting. We're working on, for the second half of this year, a solution to that problem that will give you direct access.
And this is even if, obviously you have to work with your security groups and everything like that in your own VPC.
Yeah.
But assuming your RDS instances are in private subnets and all that, you have to kind of figure out how to...
So no problem integrating it from an application standpoint.
Yeah.
But from the data ingress and egress, right now there's the whitelisting technique, and we're going to have an additional one that doesn't rely on whitelisting at all. But just so you know, essentially every customer that I know of that uses our private spaces will peer it to one or more AWS VPCs for the reasons you mentioned.
Okay, thank you.
Sure. Hi. Thank you.
The idea was that we have data which I sync up on Heroku. I want peering done with others, but the peering can also push data onto that. Is there a way for the Heroku to connect, just as it connects to Salesforce, to connect on this side?
To RDS, for example. Yeah, so can Heroku Connect work with RDS? RDS has a Postgres database. The answer is it's not supported. And we don't support it. I'll be very honest with you. The Connect as the service has been, it's been growing so fast that we built a lot of tools to make it easy to support it that are specific to Heroku. Functionally, it's Postgres. That's not the reason. It's really just from a support standpoint, we can't take that load on, so we don't support that today.
Okay.
Yeah.
We can technically do it, but not to the built-in Heroku things.
Yeah, exactly. Yeah. Thank you very much, everyone. Appreciate it. Yeah, exactly. Maybe we will.